the Sepik lowland forest in the northern part of the center, Papua New Guinea, and we see the rainforest, mostly flooded rainforest, because we see sagu palms everywhere, Metroxylon sagu, which is so important for all the people living in the Sepik river area. But what is incredible, we see tens of kilometers only covered with this almost untouched lowland rainforest. Mucuna bennettii. Incredible sight for a botanist. This is the flame of the forest. It's a Mucuna bennettii. We know it in all tropical gardens, but here we see it growing wild along the river. Wow! This climbing plant, it's a member, of course, of the Leguminosae, Papilionaceae. We see the leaves, the foliolate leaves. It's close to the jade vine, which is blue. And here we see the inflorescence. Here it's growing along the banks of the river, but it can also climb on the trees inside the forest and reach the canopy. So it is very adaptable actually, both to wet areas and not so wet areas. But here it's very interesting because along the river it's very easy to see, and we are lucky because it's flowering now. It's the end of the rainy season. Usually we are waiting for these flowers in the dry season, but now it's the end of the rainy season. We see this perfectly flowering and creating all these hanging curtains of leaves. see? They did collect the breadfruit, the Artocarpus fruit, because actually here it seems that the Artocarpus, if I remember it's Artocarpus altilis, is really growing wild in this swamp forest. It's a freshwater swamp forest, and they use them, but it seems they are native. The Artocarpus, we see a big one here, and they cook and they eat, so they live mostly on the sagu palm, on the breadfruit, but it's a good food. And fish, because they have fish also. Always in monoxyle pirogues, made in one trunk only. So we are in front of the spirit house in the Sepik river, more precisely Karawari river, and we see these walls are made of sagu palm leaves, and we see algae growing at the periphery because it's of course very humid. Here it's made with bamboo leaves also, so it's a mix of bamboo leaves and mostly sago Metroxylon leaves, and the global shape is an evocation of the waves of the river and waves also of the sea, of course. We see the big head. We see a patch of Cyrtosperma, which are typical aquatic members of Araceae. We can find similar species in tropical Africa and tropical America, but of course the genus Cyrtosperma is from Asia. And here in New Guinea we can find the biggest species. We see here, for instance, the leaves are about 2 meters high. These ones are smaller. Rain is coming, I think. It was so beautiful day, sunny day, so now 4:30. It will be good because it's a little bit hot, so already the fresh air just before the storm. But mostly I was so happy to see the Mucuna bennettii in its habitat. Last time I saw it, it was in the New York Botanical Garden in winter, in January, flowering in glass house, of course. But I could not at all imagine it was growing in a swamp forest like this, especially on the edges of the forest with the roots inside the water. Big surprise, this. No more wind. Just after heavy rains during many hours. Now we cannot speak about sunshine, but a little bit more light, and immediately we see that all the humidity is emerging from the forest because all the leaves are covered and of course with water. And now we see that the new clouds are forming now, so everything is ready for the next rain now. Hopefully in our place we can drink something, and it's easier to wait, of course. We are now in these swampy areas along the rivers in the Sepik area, along the Karawari River. We see that, of course, it's most often flooded, and it's a typical habitat for the Metroxylon palm. Of course, there are some other palms we see here. Also, Artocarpus is growing here. Many different species, so it's a very special habitat, and this is actually the habitat where the Papuas, Lowland Papuas, are living, where they build their houses, because they use trunks of many palms. Caryota, for instance, they use Caryota fish-tail palm to have the pillars for the houses. They use also another palm for the floors of the houses. So, me, of course, for a botanist in loving understory plants, shade-loving plants, there are very few things because it's very often totally submerged by water. So we see there are simply seedlings of trees and very few plants living in understory. But maybe, I'm sure, when we continue we can find some Araceae, for instance, some Schismatoglottis. I can see a Pandanus, of course. This is the world also of the Pandanus. Here I see a climbing Araceae, probably the young stage of a Rhaphidophora, climbing on the trees. Here also a climbing ficus, typical of the Asian ficus species, climbing along the trunks in forest understory. Pandanus, it has already stilt roots to be maintained above the water level. Many rattans, we see this huge rattan stem here, and many species of rattan, some fish-tail, probably Cortalsia, and many other genera. Of course, and local people obviously use rattans and ferns, and so it's New Guinea is very rich in many types of plants. We see a beautiful Musenda of the coffee family, a member of Rubiaceae. So it's a climbing plant growing on all the shrubs around here, some ficus, some Dillenia. We see the yellow tubular flower and around the big white flag. On this flag actually is a sepal. It's not a bract, it's not a modified leaf, it's a sepal, so it's a part of a calyx, and one of the sepal is increasing. So we see these Musanda actually, we can see them in Africa, in Southeast Asia. In New Guinea, of course, it's not the same species, and this one is very noticeable because it has very wide and very bright white flags, sometimes not so bright. And we listen also the birds. Climbing rubiaceae with bright pearl-like white fruits, exactly pearls, and hanging. I don't know which genus it is at all. Of course, obviously today different from Musanda, but rubiaceae, when we see the stipules between the leaves, no doubt. Huge hydnophyton, not only one, but 1, 2, 3, with huge tubers with empty cavities where the ants are nesting. This hydnophyton has a very special tuber with many protuberances, and it's a little bit coral-like or mushroom-like or a little bit disgusting-like, but actually it's a very beautiful structure. And the ants are happy inside this incredible. We see some ants climbing on it. We are in New Guinea and everything is giant. I've seen hydnophyton everywhere in Malaysia, in Borneo, in Sumatra, but never seen so huge. It's about maybe 80 centimeters high and 50 centimeters wide, probably at least 10 or 15 kilograms. And we see the branches of this rubiaceous plant. So once again, New Guinea is giant. And with it we see this very beautiful epiphytic lycopodium, probably Rupersia, but I've never seen this species. It's not one of the common like Squarosome or Phlegmaia. It's another epiphytic lycopodium, Rupersia. Il est énorme le hydnophytum là-haut. C'est quoi la petite plante qu'il y a avec? C'est un peu péromia ou quoi? Ouais, Oya. Ouais, non, bah, la petite plante qu'il y a avec. We see the typical leaf shape of the pothos with articulate leaf in two parts, totally winged first part of the leaf, and in this case it's remarkable to see the bright red fruits. This plant is a quite common plant in Southeast Asia and also here in New Guinea. It's an Anguana malayana with a long stolon creeping at the edges of the water, and it becomes large floating mats, and we see all this stolon-like structure. So it gives large clumps, Penguina malayana.
That's nice.
Probably a Cyperacea, but I don't know at all this one. It's not a, because I hesitate with Pandanus, but I think probably a Cyperacea, but the roots are very big for Cyperacea roots. I know there is another important genus in Australia, member of a Ginkaginaceae, quite small family, and maybe it could be a triglokin, which is typically aquatic. Very interesting aquatic plant. Actually, this very strange aquatic plant with long stolons covering all the water surface actually is a Pandanus. But because we see when it becomes bigger, we see the sharp spines. Qu'est-ce que c'est la même chose? Est-ce qu'il n'y a pas deux choses en mélange? Something remains strange because this plant is very green on the underside, whereas what is obviously a Pandanus is glaucous underside. So I'm wondering if we have not two different species mixed. I see the ovary at the end of the pistil. It's a Caparidaceae, family of caper, trifoliolate leaves. And actually, when we see the ovary, the fruit developing at the end of the style of the pistil, so typical of Caparidaceae caper family. We see all the ovaries at the end developing in fruit, and in these flowers we see the yellow petal, we see the pink stamens, and we see the ovary at the end of the green style pistil and developing fruit at the periphery of the flower. So this is typical of caper family Caparidaceae. We see this small Fresinecia species. What's incredible is the size. It's really a very small species. We did leave the swamp forest along the river. Now we are maybe 100 meters above the level of the river, so it's what's called terra firme forest in Amazonia, for instance. It's forest on drainage, and I see here this very strange little thing. It's a Fresinecia, so a climbing Pandanus, but I did never see such a small species of Fresinecia. It reminds also a little bit of Artocarpus in Cyclanthaceae from America, but we see clearly the indentation that it is a Fresinecia. I really wonder how is the adult form. Obviously it will remain a small species, but I should like how big is the adult, so I hope we'll see it. Here we see a more usual Fresinecia, bigger. The tiny Fresinecia and more usual Fresinecia. It comes very high and it remains as a juvenile. You see very high, 10 meters, because I try to see above that. I see a fern, but it's not the Fresinecia. Yes, this is a lowland forest. Here it's a schismatoglottis, and it is very perfectly spotted. It's totally silver spotted, and the blade is dark green. We see here a young leaf with perfect design. This leaf is old because it is already covered with mosses, lichens, and hepatics and algae, of course. So, but we can see the silver spots between these. The cauliflower tree. I don't know at all what it is. It's not at all Ananacea. I don't know. We see this begonia. It's the green form of a species, and we see the hair on the surface of the leaf, and of course it's bullate just at the base of the hair, and it's more dense green as usual. It's a kind of optic fiber and concentrating the light to the cells just at the base of the erect hair, because the hair is almost transparent, reddish transparent. So this is a brown form of the same begonia species. Brown because under surface is partly reddish, we can see. So the green of the chlorophyll on the top and the red of the anthocyanins on the underleaf surface gives this global brownish color. We see a male flower. We see it's clearly a begonia and not a symbegonia, because it is not tubular flowers contrary to the one we did see on Rwandan Ridge, Mount Hagen area. So we see a very small fern, a forest floor fern. It's a member of the genus Schizea. I think maybe this one is Schizea dichotoma. There are not so many species, and it's a very small fern. Sorry, at the periphery of this decompound frond of this Schizea fern, and we see that each story is divided into some parts, 5 or 6 parts, and of course the spores are released in the air, and it's one of the few ferns germinating underground, probably associated with fungi, because most ferns are germinating among mosses or tree trunks, but this one is germinating on the soil. So in this case, probably it's an association with fungus for the germination. We see this very beautiful shrubby rubiaceae. It's not a big plant, it's erect, it's about 1.2 meters high. It has very beautiful flowers, and it's interesting because it's contorted in the same way as many Apocynaceae, but it has no latex, and we see the stipules, so obviously it is a rubiaceae, but very reminiscent of some understory Apocynaceae. It's very, very beautiful. Probably fragrant at night, especially. We see the same rubiaceae with the beautiful white flower and young stems here, leaves, and here we see the big orange fruit. It releases seeds embedded in a pulp, and maybe fruit bats and hornbills will be happy with it. Cordyline terminalis, with so many varieties cultivated all over the world, but here in native habitats. So we see a very interesting plant. It's an erect species of Fraissinesia, not climbing, but erect, and I see it's a Fraissinesia because I see the flowering at the end of the shoot with the bract, typical of Fraissinesia. Here a younger one. The fruits of the Fraissinesia. So we are at the top of the hill above our Karawari river, and we see all the swamp forest. Behind the volcanoes is a big Chambry Lake, all the Sepik area. In the north part of Papua New Guinea, in Lowland, is swamp forest, so it's the world, of course, of the sagu palm. It's interesting because we see Meremia peltata. It is the plant of the morning glory family, growing everywhere. There is an interesting fact about Meremia peltata. It is native, but now, since about 20 years, it grows more and more everywhere and covers more and more the trees and kills them. And it seems that this species is very sensitive to the increase of carbon dioxide in the air. Of course, 100 years ago, when it was less than 300 ppm of CO2, it was very different from now. We have more than 400 ppm of CO2, so it did increase by about 1/3 in a little bit more than 100 years, and it seems, according to the species, some are very sensitive to increase of CO2, some are less sensitive, but it seems that this Meremia peltata is very happy with this huge amount of CO2, and this is a big problem because it is so vigorous, growing so fast and covering the trees and killing the trees and block regeneration of the other species of the forest. So we see the effect of increase of CO2 in very remote areas such as the center of Papua New Guinea, for instance. So it's really, of course, a global problem of the world today. We see this very special fern, totally appressed to the trunk in the same way as many ficus or Rhaphidophora or piper, really embracing the trunk and fixed. And we see here some fronds become to be a little bit bigger and they separate a little bit from the trunk, and much higher fronds are totally different. It seems totally another species. They are perpendicular to the trunk, they are light green, so it's really a metamorphosis between the young appressed, we call this shingle leaf stage, really turning and appressed to the trunk and adult phase here. I don't remember the name, I have to check. I think on Mount Kinabalu I did see a quite similar fern, but maybe many can be like this. We see that the breadfruit tree is self-regenerating, Artocarpus altilis, so the seeds are dispersed mostly by the fruit bats, the giant foxes. It's an ananas, member of Ananaceae, Cauliflorus ananaceae. Actually, it's each time only one flower, each ovary is separate and each ovary develops in a single fruit. It was different flowers, but actually it's only one, and we see at the base the 3 sepals. So I don't know, there are so many Ananaceae in the forest, both climbing on trees. I think this one is not edible for us, but probably for cassowary. I was thinking it was a clerodendron because from underside I did see what I did think was red calyx and the seeds in the middle, but actually it's a very strange structure. Obviously it's not a clerodendron because leaves are alternate and not opposite. Actually I don't know if it's a flower or inflorescence, maybe it's simply a flower. When I look on the other side, there is a structure at the base which look like a kind of involucral set of bracts. What is this? It looks really like a very primitive flower. I could think maybe a Monimiaceae, but leaves are alternate and not opposite as in Monimiaceae. But I think really something very primitive when I look at the structure. I have really to try to know what is this tree. It could look like an open fig. Yeah, maybe it should be an inflorescence cycle of Moraceae. These very beautiful light brown leaves belong to a terrestrial orchid, maybe a Malaxis or related genus. The leaves are wavy, velvety, due to dome-shaped cells of the epidermis, and totally beige, not really brown, but beige. This is probably the most iconic flower of New Guinea, the flame of the forest, Mucuna bennettii. We see it just along a small forest stream, but not along the big Karawari river. It's a climbing in the forest, and we see it is cauliflorus. We see the flowers along the stems, and here we see this incredible thing. So really cauliflorus. So flowering on the top, in the middle, and down, and of course not the same individuals, but different plants are flowering all the year round, either in rainy or dry season. A huge ficus, actually like a banyan fig, because we see all the new shoots, which are actually not shoots but roots, pillar roots. Some parts look like strangling because it seems that it covers some trunks. Some parts are simply new stilt roots. So it's between strangling and banyan ficus. Strange. So we are in one of those typical swampy areas of all these lowlands in the Sepik area, and especially the Karawari River distribution. And here we see, for instance, a Cyrtosperma leaf. It's a huge arracé of these swampy areas. We see inflorescence here. We see many Alocasia here, and most important for people living here, we see a very beautiful clump of Metroxylon sagu, the sagu palm, which is so useful for the people. Now they still wait a little bit more to have a higher trunk before cutting it, and they cut, of course, before it is flowering. So all the life of the Sepik area is connected to this sagu palm. So the sagu palm is the main source of food because it is very rich in starch, and actually people don't need to grow them because they grow by themselves all along the tributaries of the river, and you have thousands of them. There are two different types, one which is very spiny, and the other one which is not at all spiny. So I have to check to know if this means two different varieties, or if it's an old selection by Papuans, or if it's two different species, but both are useful. Usually they cut it when it's some meters high, same as these ones, because after each stem is flowering, and after flowering it dies. And to collect the best starch, of course, it's before they reach the flowering stage, just before. So they cut it. The stem is some meters long, and they remove all outer parts, and they keep only the inner core, very rich in starch. And after treatment, very difficult treatment, because they have to battle heavily to cut in small, very small pieces, and then they mix in water, and finally through a kind of net made of the fibers of the forest, they collect the juice, and this juice is a mix of water, of course, and the starch. And after some time, starch is deposited at the bottom of the dishes, and they collect this starch, which is the most important food resource for all the people living here. We see here the Artocarpus altilis, the breadfruit tree, which has also the typical huge leaves of New Guinean plants, and the seeds are a very important source of food. Also, not to grow them because the bats, fruit-eating bats, flying foxes, are eating the fruits and dispersing the seeds all along these tributaries of the rivers. So the two main most important sources of food for people living in this Sepik area are the sagu palm and breadfruit tree.
Good, sweet.
Bonjour, mademoiselle.
Bonjour, mademoiselle Jaune.
Oh, elle nous aime, hein?
Ah oui, c'est... So we see this fence totally planted with the croton. Actually, same as for Cordyline terminalis, is originating from New Guinea. And many selections have been made all over the world, but even here, directly in Papua New Guinea, they have selection with, of course, very colored leaves, and also what is important, many different shapes of the leaves. So it's funny to see that two most common plants in tropical gardens of all over the world are two plants actually from New Guinea, and both of them have given very colorful leaved selection. So it's very strange to see that in New Guinea you can have understory plants with green leaves which can give new varieties with very brightly colored leaves. We see on this Cordyline terminalis a very interesting phenomenon, because actually we see the young leaves are green, so probably it is a wild form from the forest. But what's interesting is that when it is in full sun, the leaves become pink, they accumulate anthocyanins. So it means instead of dying, of being dead and totally burnt by the sun, they are protected because they create a protection with anthocyanins on the surface of the leaves. So probably this is due to the origin of the selection of permanent anthocyaninic yellow and mostly anthocyaninic pink and red leaves, because spontaneously the plant is able to produce these anthocyanins. So it was easier, of course, for selection. So this is the natural form of Cordyline terminalis. All over the world, there are many varieties of Cordyline terminalis which are cultivated, mostly with pink or red color of leaves. And it's very important also, for instance, in New Guinea, they install in front of the orchard because it has a very good reputation of protecting against the bad spirits, against everything. But this is the wild one which is always green. And as we see, in nature it's growing in shaded areas, in forest understory, but the pink and red color forms are perfectly well adapted also to full sunlight. So I'm very happy to see the original Cordyline terminalis. Yeah, this is a juvenile of Epipremnum striatum, a very beautiful member of the family Araceae, and we see the grey leaves, and it's usually growing along the trees, but here we see it has flagelliferous stems, so it will grow from tree to tree. It is known in botanical gardens, but it is, of course, obviously originating from New Guinea. Here there are plenty of staghorn ferns. This one is probably the biggest of the world. It's probably Platycerium Wilhelminae reginae, for the queen Wilhelm. It is quite common even on low branches, even in secondary forests. In this Platycerium we see very distinctly the three types of fronds. These are the pending fronds, which are mostly for photosynthesis. We see at the top all the basket fronds collecting all the dead leaves falling from the forest canopy and creating the big basket of humus in the center, and in the middle the fertile frond with the brown sorry just under the surface of this frond, which will release all the spory, giving birth to all the new ferns. And we see that this fertile frond is one part, lateral basal part of the huge green photosynthetic frond. This climbing species is a member of the genus Pothos in the Araceae. We see it's not, for instance, Rhaphidophora, because we see the network of the veins, which is very anastomosing. So this is typical of Pothos. It belongs to the section Allopothos. But what is very typical of many plants from New Guinea is that this one has huge leaves, because usually pothos have leaves only about 10 centimeters long, sometimes like this, but never wide. This one we see is 25-30 centimeters long. And this is a very strange thing about New Guinea. Many plants in very closely allied species suddenly in New Guinea have bigger leaves than anywhere around in Borneo, in Malaysia. So what does it mean? Is it a transgenic situation? Maybe it's through fungi or viruses or bacteria, which did give some genes of gigantism in New Guinea. Difficult to know, because it cannot be adaptative, because adaptation, why plants should be bigger in New Guinea, no reason for that. But obviously, New Guinea is the country of the giants. Here we have another example. This is a climbing species of piper. And we see that this climbing species has absolutely huge leaves. I've never seen a climbing piper with so big leaves, either in tropical America, where there are so many piper species. The size of the leaf on the main stem leaves are totally symmetric. On the branches they are asymmetric, but anywhere, everywhere, these are huge, absolutely huge leaves. It's an Alpinia species, so many Alpinia species in Southeast Asia and also in New Guinea, but up to Solomon Islands and in all these areas, many different species of Alpinia. It's one of the very few genera easy to identify among gingers, because it has terminal inflorescence, either drooping like this or erect inflorescence. A member of the Euphorbiaceae with typical three-parted fruit, three coccus fleshy fruit, sometimes fleshy, sometimes not fleshy. Also very typical of many Euphorbiaceae, we see the small indentation of the leaf. Sometimes some glands. I don't know if in this one we can see glands. No, I don't see glands on the leaf, but we see perfectly indentation. Maybe an Excoecaria, but sure, Euphorbiaceae, sensu-lato, of course, Euphorbiaceae or Philantaceae. Another example of gigantism in New Guinea. This plant is a very common aroid in all over Asia. You can see it in Malaysia, in Thailand, in Borneo. Of course, in New Guinea, it is much bigger. Usually, this one is at least almost double size of the usual size of the leaf, because usually it's 50 centimeters long, but these ones are more than 1 meter long. One of the quite few understory palm. If I remember correctly, I think the genus is Hydriastele. I have to check. And it looks a little bit like Pilanga in Asia, but it's different. We see inflorescence is a long drooping axis like this. It is also forming groups of stems, tufts, but ici also we see a more classical liquala. But this should be Hydriastele. We see in heliconia here. Most heliconias are from America, but there are very few species in Asia, especially in the Fiji Islands, in Solomon Islands, in all this area. And here we are in New Guinea, so maybe it is an indigenous species. I say that because I see that fecundation is done, because we see all the developing orange fruits. So maybe this is one native species. I have to check this because it should be my first Pacific heliconia. The piper with totally cordate leaves. When I did see it, I did not know if it was a Dioscorea or something else, or a juvenile form of member of Araceae, like a Cyrtosperma, but no, it's a piper climbing all along the ground with roots, adventitious roots, and then climbing on the tree. I think it's a member of the Marantaceae. I had some hesitation with Patphyllum, but I think it's a Marantaceae, but I did never see so huge entire leaves in Marantaceae. One of the many species of climbing piper. This one has very beautifully textured bullate leaves and climbing along the stem. A wild, a native banana species, a musa, and it's the tallest I've ever seen, with inflorescence and fruit. They are about 12 meters high only for this type. This Platycerium actually is probably Platycerium Wilhelminae reginae, has actually 5 different parts of the leaves of the frond. Of course, there is a huge sterile part, but the sterile part, one part is totally open, collecting dead leaves. The other part is totally appressed to the tree trunk and creating the fixation of the plant. So this is one frond. The other frond is a photosynthetic one, which is hanging, you see here, and also at the top, another part of this frond is covered by the spores just under the surface. And there is also another totally curled part in the middle, protecting the growing apex of the fern. It is actually an expansion of the sterile frond, turning there on with all these small curly structures totally protecting the apex, the growth bud of the plant. So it's incredible for only one plant to have 5 different structural functional leaves. Here we see that even the so common Hypomea pes-caprae subspecies brasiliensis also has much bigger leaves than usual on the beaches. It's one of the common beach species, but usually we see here the leaves are much bigger than usual, big stems. This gigantic event even in a common species like this. Even the so common Hibiscus tiliaceus, which we can find on most beaches of the world, here in New Guinea has huge leaves, much bigger than usual. Usually it's a smaller leaves, usually size maximum like this, most often this size, but here we see that most of the leaves are much bigger.
Qu'est-ce que tu regardes?
I look at all these cycads. A huge population of cycads growing on the slopes, and it's interesting because we see the trunk is burned, but they survive perfectly to each burning season. Some are probably very old because we see trunks which are already 2 or 3 meters tall. So it means some are maybe 200 years old or something like that. We see a huge Mur Végétal ant plant, family Rubiaceae, growing on the trunk of Casuarina, because we are in Varirata National Park, very close to Port Moresby, so on the south coast of Papua New Guinea, and we see everywhere cycads and eucalyptus. Dominant tree is a eucalypt mixed with the Casuarina. So this is very reminiscent of Australia, but the Mur Végétal are very New Guinean. Very surprising when we leave all the humid forests of the mountains of the center, which has totally different flora, suddenly to go back to something much more Australian. We see here climbing a Rhaphidophora in the Araceae, and it has very thick leaves. It's not surprising because here the dry season is very dry, but what is quite funny and unusual is to see Rhaphidophora climbing on a Casuarina trees. Another ant plant, still a Rubiaceae, but this time it's a Hydenophytum. It's not Mur Végétal. We see that the shape of the tuber is totally different. Here in this case there are many stems arising from some spots on this huge tuber. There is of course a very close relationship between the plant and the ants. The plant has already, while growing, some cavities inside, but when the ants are penetrating, they are foraging and they dig out also some material, so the cavities become bigger and bigger. So for the plant it's a benefit because the ants release different plant materials and the dejections, so it's of course it's a source of minerals for the plant, and also these huge tubers keep humidity. In dry season it's very important, and the plant is protected by the ants from all the caterpillars and other insects susceptible to eat the leaves. And we see that the leaves are absolutely intact, not a single hole in the leaves, probably thanks to the ants living inside. I look at exactly what we see. I was thinking it was a Schefflera, but actually no, it's not a Schefflera. It's a Vitaceae, so maybe a Cissus or something like that. I see it's the swollen nodes, the base of the leaves, so it's a climbing plant of the grape family. We see here the Vitaceae climbing in the same way as the Ruicissus in Australia, for instance, or some other Cissus like Cissus hypoglocca, also in Australia, and also same as some Tetrastigma, typical Vitaceae, but with thick leaves because this forest is very dry during the dry season. Yes, this very branched Fresinecia. It's branched everywhere. It's not at all usual to see this. Everywhere we see the stop growth and then new stem and new stems arising. We should like to see inflorescence, but not in this season, or simply not now. There are some reminiscences of the rainforest here. For instance, here we see a climbing medinilla with 4 leaves at each group of leaves, and so this is much more typical of tropical rainforest. Also this climbing Apocynaceae. So we have really here a mix of dry and tropical humid rainforest. Beautiful whirls of leaves. The population of an orchid species colonizing this strain, but what is strange is that they are so closely packed together, because we know that the seeds of orchids are dispersed by wind very far from the parent plant, but here they choose not to go far, at least for many of them, and they are germinating on the same bark as the parent plants. We see also that they have a fan-shaped arrangement of the leaves, which allows the accumulation of the dead leaves, creating humus. So it's also a kind of basket orchid. This shrub, the Melastomataceae, is the same group, probably the same genus as the one we did see 2 days ago at 2,000 meters above sea level. Here we are only 800 meters above sea level. In Ambua, in Tari, and we see the flowers, terminal panicles of flower, and we see also the bright iridescent green young leaves. We see a beautiful epiphytic fern, a basket fern. When we look on the riverside, we see that the sori are totally continuously distributed on the undersurface, at least for the last 2/3 part of the frond. For me, it reminds me something like an Elaphoglossum. It has very thick leaves in the same way as many Elaphoglossum. These climbing plants really looking like a quite usual Esculentus. Actually, it's not at all an Esculentus, but it's a Rubiaceae, because I see the stipules between the two opposite leaves. So it may be a group of the climbing Psychotria or some other genus. A very dense, shrubby Selaginella, totally branched all along the stem. Many orders, successive orders of ramification, and this is not at all usual among the Selaginella. And we see the main stem is very, very thick and rigid, and so it's very unusual for Selaginella to have this growth habit. I'm looking at the inflorescence of a dense population of a Chlorantaceae, and I wonder if it's a Chloranthus or Sarcandra. Difference in the stamens. Actually, stamens seem simple, so maybe it's a Sarcandra. So I'm surprised to see this one in South New Guinea, because for me it's mostly a Malaysian plant and also Chinese and Japanese, but I'm surprised to see so close to Australia. It's another species, but of course of this primitive family, which was already here when dinosaurs were probably eating a lot of these Chloranthaceae. So we see here the new young stilt roots of this huge Pandanus, and we see that the extremity of the root is totally protected by this part which goes along with the root and protects the growing apex at the end of the root. We see on all these young roots. It's I think the tallest Pandanus about stilt roots I have ever seen, this one.
Very special bark.
A very special bark peeling from the bottom upwards, and of course I don't know at all what it is, but it's very beautiful to me.
Madang.